For this last section on HVAC, we're going to be covering an older system, which is the CCOT system. CCOT stands for Cycling Clutch Orifice Tube. It had a fixed orifice, which you can see the image down there at the bottom, where you see that black O-ring. There was just a small restriction, just literally a small hole right in there. Because that hole couldn't change, this did not have the ability to compensate for a hot day, a cool day, for high RPM, for low RPM. So this system would flood the evaporator, causing the evaporator to get too cold. So what they had to do was shut the AC compressor off, hence the name cycling clutch. In the image in the lower right, you can see the dimple that is on the pipe right there. That's where your orifice is located at. To identify this system, you're going to look at the firewall. You see the two lines coming in there. The larger of the two lines is going to be the line that returns the refrigerant back to the compressor. If that line goes straight to the compressor, nothing else on there, it's going to be a TXV system. However, if it's got this accumulator on there, then you have a CCOT system. Less expensive, so some of the manufacturers like using this. GM, Ford in particular, use this for a long time. In fact, that image that you're looking at in the lower right corner, that's an 05 Silverado that still had the CCOT system. I don't know of any European cars that ever used this, and there are very few Asian manufacturers that use this system. So looking at the accumulator is going to do just the opposite job that the receiver dryer did. The receiver dryer was set up to make sure that it was only a liquid refrigerant that got to the TXV. The accumulator is going to make sure that it is just a vapor that gets to the compressor. So you can see here at the top on the inside of the accumulator, that's where they're going to draw the refrigerant in. You can see if there's a liquid that comes through there, it's going to sit in the bottom and it'll boil away and turn it back into a vapor. But this tube goes down to the bottom and they have this filter, and there's a small hole down there. The oil that's circulating through the system, if they didn't have this set up like this, it would just fill the accumulator with oil. So they got that tube running to the bottom. They've got a small hole that's going to draw the oil out of there and keep the oil circulating. So primary job of the accumulator is to make sure that we have just a vapor going to the compressor. Primary job of the receiver dryer was to make sure that we have just a liquid going to the TXV. Now we're going to cover through the switches and sensors that are used on the system. And different manufacturers used different types of switches and sensors over the years. And we're just going to do a basic overview of the ones that are on there. You'll have to look at the information for the specific vehicle that you're working on to find out how that one is controlled. First one we're going to look at, this is a temperature cycling switch. That probe is jammed into the into the evaporator. And I always hated installing these because as you stick that probe in there, you're bending those little aluminum fins, and I was always afraid I was going to cause a hole when I was doing it. That's looking at the surface temperature. So as we've been talking about the system and we've been talking about the refrigerant, we've been talking about the pressure-temperature relationships, and that's the refrigerant on the inside. This is going to be on the surface. So we were working on a car just yesterday that the refrigerant was at 21 psi, meaning it's well below freezing, but the system continued to run because the surface of the evaporator was not getting down to the 32 degrees. And so the system just continued to run normally. So one of the things that you'll find is they have a low pressure cutout switch, and typically that low pressure cutout switch is going to shut the compressor off in the 20 psi, 28 psi, somewhere in that range there. But you will find systems that are running even if they're below the low pressure cutout, and that's because they're using the temperature cycling switch, and that low pressure cutout is actually on the high side of the circuit. So this one here is on a CCOT system, so that switch screws right onto the accumulator, and it is a low pressure switch, but they're going to call it a cycling switch because on this system it kicks the the compressor on and off while the engine is running while you're driving down the road. So typical, upper 20s is where it's going to shut off at, and then when the refrigerant pressure gets back up to low 40s is where it'll kick back on. Now with a CCOT system, because you have almost a 20 psi range, 15 to 20 psi, your evaporator is going to get colder and warmer as it's running. So if a person is holding their hand up there and paying attention, you'll feel the air temperature difference on that system while the vehicle is running. That isn't broke. That's the way the system is designed to run. So hopefully you don't get that complaint from the customer because the system's not broke. Customer is. All systems have a high pressure cutout switch. The high pressure cutout switch is going to shut off somewhere over 400 psi. Now, high side pressure should never be getting up into that high. So typically, if you do have a system that's getting up over 400 psi, it is going to be either way overcharged or the condenser fan has failed. So it just can't get rid of the heat. This one here is a style that typically we'll find mounted into the back of the compressor, but the high pressure cutout can be located anywhere on the high side of the system. So on the discharge line coming from the AC compressor, condenser, receiver dryer, somewhere in that area there. It would cut off, somewhere in the 400s and probably turn back on once the pressure got down closer to 300 psi. Now, this one here, a lot of the Asian manufacturers use what they call a dual pressure switch. This is the low pressure cutout switch and the high pressure cutout switch, both built into one unit. So this would typically, again, the low pressure is going to be in mid to upper 20s is where the system would shut off. But once the AC compressor kicks on, this is on the high side of the system, so the pressure will never go low. It'll run all the time. The only time this switch is going to work is if your pressure is below if it was set at 28 psi, if the pressure in the system was below 28 psi, it would prevent it from turning on. So if you have real cold temperatures, this switch could be open as you start the engine and run the engine. Temperatures under the hood are going to come up, pressure is going to come up, and then it would kick on. And then the high pressure switch is just like we described on the other manufacturers. Now, if you have an automatic climate control system, and this, if you're not familiar with it, on the manual systems, you're going to choose warm, cold, somewhere in between there for what you want. On an automatic system, you set the temperature that you want, and the AC system is going to send the air to the floor, out the vent, depending on if it's warmer or colder inside the car than what you were wanting. Now, the sun, as it shines on the car and through the windshield particularly, can generate a lot of heat inside the car. They refer to it as a sun load because it's heating up the interior, and they have this sensor mounted on the dash that is measuring how much sun is shining in there. The computer is programmed to be able to compensate for that. So I was driving through Eastern Washington one time. I wanted 72 degrees, I wanted 74 degrees inside the car. Outside temperature was 72 degrees, and it turned the AC on. And the reason it turned the AC on is because the car that I was driving had a windshield that was about the size of a twin mattress. So a lot of heat being generated from that. The computer was trying to compensate for it. They will also have a number of temperature sensors, and by a number. Some of them will have just a couple of them, but some of the cars, especially the newer ones, they will have 5, 6, 7, 8 different temperature sensors located in different places. So this one that we're looking at here is on the front of the car, up in front of the radiator, and this is your ambient temperature sensor. So a lot of the manufacturers put the ambient temperature sensor in front of the radiator while you're driving along. That way none of the heat from the engine can affect this. Now, when you come to a stop, heat from the radiator is going to affect this reading. The computer is programmed to ignore that sensor changes while the vehicle is standing still. Once you begin moving, again, the computer's going to wait a little while and then say, okay, now I can trust this reading. Now, the same thing will happen when you shut the car off. The computer stays awake, and it's got a timer up to 6 hours that it's waiting, and what it's looking at is that radiator engine compartment can still be hot up to 6 hours later, so they won't trust that ambient temperature sensor until the vehicle gets moving above a certain speed and for a certain length of time, and then that temperature will update. A couple decades back, or a few decades back, manufacturers started coming out with what they call a dual zone. And what they were doing is allowing the temperature to be set differently for the passenger side than the driver's side. Once I started seeing these coming up, I could not wait to get one of these vehicles for myself, because my wife likes things a whole lot warmer than I do. So you can set different temperatures. Vehicles can maintain, depending on the vehicle and what the manufacturer claims, but I've seen at least 5 degrees difference or more between driver's side and passenger side. Now, on the early systems, the way that they did this, the only difference was the temperature door, that it could either move the air through the heater core or around the heater core. So driver's side, that was the master. So if the drivers wanted it cool, air is going to come out the vent. So even if the passenger did full hot, the air was coming out the vent still. Now on some of the newer ones, they have the ability to change so that driver's side can come out the vent, passenger side out the floor. But this is the key to it, is by having 2 temperature doors instead of 1 through the heater core. And now with the popularity of the SUVs, a lot of vehicles out there are at least a 3 zone. So they have a passenger side, a driver's side, and then you have the rear zone to be able to control the temperature back there. And there will be controls in the front, and most of the manufacturers put controls in the back also. So on these rear zones, the AC compressor, so there's 1 AC compressor, there's 1 condenser, 1 receiver dryer, but then what you're going to have is your tubes split, and there's 2 TXVs and 2 evaporators, 1 in the front under the dash where we normally have. The second one is going to be in the back of the vehicle somewhere. So they actually have a heater core and a evaporator back there to be able to control the temperature through the rest of the vehicle. And that covers it for the AC system.